I think it's our first Wi-Fi breakout session of Fyuz, so thanks for coming to the first one. We have more scheduled through the rest of the 3 days of Fyuz, so hope you can make your way into all the other breakout sessions for Wi-Fi. There are a number of conversations around Wi-Fi in the metaverse. There's more Wi-Fi and open Wi-Fi terms, so please do find your way to all the fantastic Wi-Fi breakout sessions that are here. Thanks for joining, everyone. Again, John Crispin and myself, I'm Chris Busch. We're here, we're going to talk about the development side of open Wi-Fi for a little bit today. We are missing one of our speakers, Stefan Bork from Aurelia, was not able to join us here, last minute family emergency, so all is well, but he certainly is missed. We'll do our best to cover all of his content. A couple of slight adjustments to our agenda as we go forward. We did want to do live demos while we were together, and we're not hooked up for that. We didn't quite have the technology to do that. So whenever we see live demo call-outs in the presentations, just know that we'll set up beside the meta booth upstairs, days 2 and 3. And I'm happy to do one-on-one conversations with anyone who's interested to go further into whether it's aspects of the controller or the provisioning service or firmware or otherwise. We'll take that on as we go. Okay. So we'll get going. I think we have, I know it's a development summit or a developer talk, but just sort of to walk us in and get a sense of who's who together in the room. Quick show of hands. Who has used TIP OpenWiFi so far? Aha, okay. And so for the folks who've used TIP OpenWiFi, who's new to the project group this year? Aha, okay. All right. So generally speaking, we have folks that are probably familiar with the 2.x architecture and conversations such as Use Central and the types of devices that we have support for. Okay, so that's good. We'll be very focused on those topics as we go through this session. Just a couple of housekeeping bits on TIP OpenWiFi in general. It's a bit of my pleasure to introduce to all of you our new co-chair for the project group. Jack Rayner is with us. Jack, I want to say, there's Jack. So thank you, Jack, for coming on as co-chair. I couldn't be more thrilled, more happy to have Jack with us on the team, and it was my pleasure to help move the program along for the last 2.5 years. So thank you so much. So our agenda today is we're going to talk about just TIP OpenWiFi in overview terms. We'll get into the SDK itself. And what we mean by SDK, it's really about some of the cloud services that help to enable how operators consume OpenWiFi and or deploy or integrate OpenWiFi in their production networks. And so we'll talk a good deal about what are the nature of the services, what are their roles, how are they designed, how are they developed. We'll talk a lot about how we as TIP do what we basically call DevOps for Wi-Fi. So how do we build software in a continuous integration fashion? What's the pipeline look like? We'll talk a lot about that. We'll also dive into how the testing in that pipeline looks. So we'll transition then over to John. And John is core maintainer for our firmware side of the program. And so we'll get into great details on that as well, around just the essentials of understanding the embedded OS, how patches happen in that space, and how some of those patches turn into some pretty amazing features, especially work that's gone into some of the advanced data plane concepts that find themselves really only in open Wi-Fi today, and then some of the features that have already gone upstream to OpenWRT. So it's a great conversation. Again, without the live demos, we will be short on our total time. So questions, certainly as we go, happy to at any time. And again, we'll do one-on-ones upstairs at the meta booth later. Okay, so again, we covered that. I think most folks understand the 2.x architecture. So when we think about what is TIP OpenWiFi from an operator, management at scale, telemetry at scale perspective, we need to appreciate, well, what is that data model and what is that interface that's talking from the cloud down to all of the managed devices that are in your production networks? So for that, we have a conversation called Use Central. Use Central came to us by way of, we really wanted to have a community-driven and community-owned long-term solution that would allow for not just TIP OpenWiFi to be successful with high-scale management telemetry, but also for OpenWRT as an eventual upstream owner of that management telemetry to be able to hold on to that and maintain that long term. So Use Central was sort of born out of those ideas, plus the notion that what we were looking to achieve in TIP OpenWiFi was very much a middle prize, if you will, North Star. So we needed to be flexible in that data model, ability to have definition configuration for certain things we were doing in the data plane, things that we're doing in mesh, whether we're doing VXLAN or different overlay technologies, have the ability to move the data plane very quickly within a single sprint in the development team terms and meet the feature that's happened down in the device at the same time. So Use Central carries that ability. It gives us that flexibility to define new features, add them to the data model, return telemetry on those new feature builds right away. And so from a high-level perspective, what we're showing here is sort of a cross-section view. As with any client-server interaction, you have a conversation that's happening over a socket. In this case, we have a TCP WebSocket that's established. It's fully encrypted, so for those familiar with OpenWiFi at some level today, you'll know that there's a certificate that's present in the device, as well as in the gateway controller itself. There's a mutual TLS level of protection as a result on all communications. That includes telemetry. And what's happening is the Use Central agent inside the device is working to basically pull events off of the U-bus, wrap that up as telemetry, and send that on a defined interval. The interval is something that you set up as provisioned data in the device. We'll get into a lot more of that as we go through here today. What's happening when you provision down from the cloud, you're speaking down over that same WebSocket. So if you think of telemetry as always going up on some defined interval, every now and then you want to make a change, you're going to initiate that from the gateway down to the device. So it knows how to find that gateway, the gateway knows how to find a particular device by containing a table of the device serial number to a specific socket that it's speaking over. The payload that's going down there, we'll see this more specific term shortly, is going to be a compressed JSON document that will go down and contain all of the information that the device needs to essentially deserialize, and then the renderer proceeds to stub that into local configuration through, for those familiar with OpenWRT, UCI. So you can see there's a bunch of initial purpose-designed framework that helps TIP OpenWiFi not just achieve its goals of being able to rapidly introduce new features, be able to solve new cases in use cases terms for operators, usually inside of single monthly sprints, but also we're designed carefully in a way that there's an opportunity to upstream as much as we can, either to OpenWRT or within different microservices that are in the SDK. So we always sort of carry that in mind, architecturally when we look at how features work in OpenWiFi. So when we look at the cloud gateway side of this, so obviously the gateway is doing a few things for us. It's making sure that any payload that's going to be sent down to the device is syntactically correct. And so there's a couple of things that go behind that. One is it's just proper, valid JSON format. The other is that it meets with the actual data model. For any of developers, or if there are developers in the room who have looked at how the gateway is designed, you'll know that it's exceedingly flexible to working with the latest data model. You'll see there's a portion of configuration in the gateway that allows you to fetch the latest data model from Git. And so by default, the gateway is always going to be running on the last GA'd or release candidate version of the data model, but you can always override that to experiment with the latest features, and the gateway will go out to TIP's GitHub, fetch the latest data model, and then immediately your gateway is now using the latest active. So interesting way of looking at things in terms of, it's part of that continuous part of continuous integration. So you always have that rapid development ability. We'll see a few microservices in a moment, but we're being very specific by only showing the gateway here. I want to really create that clear line of separation in your mind as to the actors in northbound and southbound terms. So when we talk about Use Central, we're always talking about, from the gateway's perspective, a southbound interface to the devices in the field. And And when we talk about a REST API or other APIs, we're usually talking about a northbound interface. If it's in terms of the REST northbound interface, then that's going to be where most of your CRUD actions are happening for updating a device configuration or deleting a device or otherwise. Then we have a message bus adapter, also a northbound interface. You could maybe think of it as a horizontal interface, but northbound from the gateway's perspective. And so the gateway has that other added responsibility of essentially demultiplexing all the telemetry that's coming at scale into Kafka topics that get pushed onto the bus. So this allows for a nice decoupling for operators who have fairly expansive assurance systems that are built up, usually NOCs with large dashboards or room-sized dashboards showing the status and health of the network. They're going to be very dependent on the data that's present in the Kafka bus. And you wouldn't want to depend on that data necessarily, certainly for those assurance observation dashboards, by making a REST API call, as that would be a very heavy or more expensive way to obtain the same data. You want to decouple the load of doing assurance and surveillance of network health from the device interaction itself to a Kafka bus that's going to decouple that for you, allow you to scale much easier. Now, in terms of long held data, there's a few sources there. What's not shown here is there is time series. There's integrations with InfluxDB and Grafana that are present in the open source community. I encourage folks to have a look at that. That helps you build out different visualizations and dashboards directly off of the open source. But we also have any of our provisioning data and any of our service configuration data are held in SQL databases. These are also configurable. We'll talk about the design of the microservices as being true decoupled microservices, stateless design. So you'll see there's a mention of an ORM here. So this object relational mapping interfaces allows you to either deploy a very small system in a lab just for a quick test. If you do nothing, you'll inherit a SQLite implementation of the stack. If you configure just by changing the commented lines in the Helm configuration charts, you'll end up going into a Postgres high availability cluster. So we automate all of these actions in terms of, you'll see the Helm charts from we deploy into native Kubernetes, and also the Docker Compose YAML files for when you just want to deploy into a smaller set. And again, everything's quite visible in those YAML files as to whether you're seeking persistence for all of your provision data and other sort of device statistics into whether it's going to be SQLite or whether it's Postgres. And so where do you find the distribution information around the southbound protocol? Obviously, uCentral is a newer conversation to the industry. So we work together obviously closely with the embedded leads, which is John Crispin, and the cloud lead, which is Stefan Bork, to have that common agreement on the interface model. The model is versioned. There was a version 1, now it's version 3. So we check the versioning, obviously, when we do the handshake with the device, and that is described up on the TIP GitHub. And then all of the data schema, so how you can provision, sort of that source of truth of, hey, does TIP OpenWiFi have X feature? Now, you can actually figure that out really quickly by grabbing that GitHub link and just doing a search for the name of that feature. You'll know right away if it's in the data model, we've got it, right? OpenWiFi.tip.build is a source of online tech pubs. So the ability to go and see what maybe others have written about how to, or describe how to configure or provision or manage or install. There's lots of good, helpful information up there. Okay, this is my favorite starting out slide. Who doesn't like a sequence diagram? Now, I didn't use plant UML, so you should all be happy about that, right? It's all pretty pictures, not compressed images. So we want to sort of talk about this relationship of a device to the cloud. OpenWiFi was sort of meant for, you could deploy on premises if you wished, but also it makes a lot of architectural choices that assume there's probably a cloud scale operator or an operator looking to run as a managed service provider. So that it makes no demand on the deployment to own the infrastructure that's involved in bringing bandwidth to the premises, if that makes sense for the audience. So what we do is a device, when it first powers on, it will essentially look for its controller. The first thing a device from OpenWiFi does on power on, it obtains internet access, and it makes a well-defined API lookup to the TIP root CA authority through DigiCert. And based on using its device identity and also being challenged for its certificate, so again, that's another fully encrypted conversation, it will look up, where is my home controller? Can you tell me what operator manages me? Right, because I came from factory, and I need to know where's my home. Its answer is held in its device record up in the root CA. It's not held in the certificate, it's held in its record in the CA. So the CA will answer back with, you're with cloud provider X. It says, thank you so much. I'll close that connection, and I will never do that again until somebody hits the factory reset. It now initiates the start of this connection process to provider X. So the first thing it does is it opens up that WebSocket, goes through a TLS handshake, achieves that mutual TLS level of encryption and security, where the SDK gateway is effectively doing something very similar to what happened a moment ago when it did the lookup for its device record identity location. It's saying, I have a server-side certificate in the gateway that's also been signed by the TIP root CA, and you must come into that chain of trust if you're asking to have a connection. So of course, it's a TIP OpenWiFi device. It has a unique device certificate that's based on that device's serial number or base MAC address, at which point you now are agreed to have an ongoing WebSocket connection with the cloud. The next thing the device will do is say, these are my capabilities as part of the handshake. Developers will recognize that when you bring up a new device in TIP OpenWiFi terms, you are basically working within the OpenWRT operating system. Part of the bring up instructions will effectively describe your device make and model and its capabilities in something that's auto-generated by the built image in a board.json file sitting inside the etc directory. So if you're ever curious, what are the capabilities that the cloud is learning? Go look at the board.json file on the device, and you'll end up seeing the raw representation of that. And you can, of course, look at the JSON representation of that when you consult the gateway for that specific device connection. So based on the capabilities, the gateway is able to say, interesting, serial number, do I know you? If it has no knowledge of the device, it's never seen the device before, and the gateway has no membership of that device to a venue or a division, then the gateway has the opportunity to send a default configuration down. The important thing for cloud scale Wi-Fi service management is to always make the lights go green. They may not be the shade of green you intend for production yet, but you need the device to come online so that it can be managed, and or so that it comes online in a way in which you can have subscribers possibly be brought into a walled garden experience. Either way, you don't want to lose track of devices that are at the edge of your network, especially when you're making decisions architecturally that say you don't have to own the infrastructure that brought bandwidth so that device reached the cloud, because that's probably an expensive service call. So you always want to be able to have the device maintain that WebSocket, and you always want to have an ongoing relationship to provision that device no matter what. So we do that through this device default configuration, the long-lived WebSocket, but if the gateway does indeed have a valid configuration or has configured the device in the past, then it will go into the SQL database table based on that UID and return down the entire configuration payload for the device. So we do a few things. We'll talk down in the agent side for a moment. We send that payload down into the uCentral agent from the cloud in the device. And we're going to deserialize that entire payload. So it gets uncompressed, it gets looked at, is it valid JSON? It must be. There's an OpenWiFi gateway that made sure it was, but we'll double check. At which point then we'll look at the data model and verify that we, as in the device, at this version of firmware have the capability for everything that was described in the provisioned outcome. If there are portions of the configuration that we don't understand, perhaps because we're on an older version of the firmware, we don't yet know what these data elements are, we'll accept that. We'll blindly apply everything we know about, we'll apply everything we know about, and we'll blindly ignore the parts that we don't know about, and we'll send back status code 1 to the gateway and say, I did what you asked, except this. So that's a very good tell when you're looking at what's happening then in logs, up in the message bus. You'll know that there are devices at a certain vendor, make, model, and firmware version that are certainly alive, their provisioning, but they're not on the right firmware version to meet with all of the provision parameters that you sent. It's a good tell for the operator. Obviously, return 0 is a great return. Everything was successful, whatever the firmware version was, but the lights went green, you're in service. Otherwise, you get back an error message, and we're very verbose. We'll tell you exactly what portion of the configuration didn't make sense or how the device disagreed with what was sent down. And all this is returned back, and it's viewable as straight JSON raw from the gateway's perspective. Assuming everything's great, the final action on the device is stub that into a persisted runtime state so that the device can reboot on that known good config, and then it'll initiate its WebSocket connection at a later time, assuming the device has been rebooted for some reason. When the device reconnects to the cloud, or if it's ever been disconnected from the cloud, the device will compare its hash of its current configuration against that which the gateway believes is the most current hash. If there's a mismatch, the gateway is the source of truth, and the device will immediately be sent its proper configuration. So some folks have asked, well, we have field technicians. What we want to do is we want to give them a CLI, and we want to... No. If you want a CLI, there is a CLI for the cloud, right? If you want to have a rich technician experience, we recommend an app using API commands to the cloud, which then pass those on to the device. We really want the device experience to be as lights out, simple as possible. Right? We should be able to build an app that consumes the northbound APIs that just works natively with OpenWiFi, no matter what the device is. If you do go in and make local changes, because certainly you can do that, what will happen? At the next interval talking to the cloud, the hash will look different, and the cloud will then overstomp your config. So always best make changes from above and leave the cloud as your source of truth. So let's talk about how many microservices are in, I should have made that like a poll question. Who can tell me how many microservices are in OpenWiFi? All right, how many microservices are in TIP OpenWiFi? Anyone? No one wants to ask, no one wants to know. How many do you think, John? 7 or 8. Okay, all right, we got one answer, 7 or 8. Let's see what we have. Because I know the slide, and it's actually missing 2. This is how many? 8. I'll talk briefly to the 2 that were not showing up here. These are actually some of the newest and coolest ones. So we were really, really happy from a TIP OpenWiFi perspective. I think lots of folks know that that Meta Connectivity has been a wonderful supporter of TIP OpenWiFi. And we were thrilled that the most recent couple of microservices that were added to TIP OpenWiFi were actually added by Meta Connectivity engineers, and they were the RRM microservices. And so there's a couple of primary actors in there. In fact, there's a later slide that'll actually give a call out to the RRM microservices. And it's so cool. I'll geek out for a second, because it was the moment when we got our polyglot design, because they're not written in the same language as the other base services. But nobody knows the difference because it's a proper cloud architecture. That's my geek out moment. Okay, so what were our goals with building this SDK? We wanted to solve the plumbing problem for managed Wi-Fi services from an industry perspective. We wanted to break vendor lock-in, create a healthy disaggregated ecosystem. If anyone was at the keynotes this morning, you heard that the real power in TIP is unlocking vendor choice and operator choice through disaggregation, but it's also about how ecosystems enable a much lower cost and higher velocity engineering scale. Just period, full stop. So if TIP, through a disaggregated common architecture, can bring forward the idea that all these common encryption, security, provisioning, telemetry, assurance stories, if all of this can be consumed as one stack and maintained by the community, then all of the vendors that are here in the ecosystem don't have to do that work. And they can focus on high commercial value outcomes. You don't need to be tied up in the plumbing. It's already been solved, right? So those are some interesting ideas that we had, at least behind producing this SDK. It's something that the industry can consume en masse. and be able to provision devices from, if you've been upstairs and seen the wall, we're missing a few physical devices on the wall. Our apologies. They are, I mean, it's an old catchphrase, but it's quite true. They're stuck in customs. But there are over 24 devices that are supported by TIP OpenWiFi's nightly build environment. And so all of those devices are run by the exact same SDK. And there's easily half a dozen or more vendors represented on that wall. So it's a really fantastic outcome that you can provision every single one of those the exact same way. You can manage all of those the exact same way. You can get common abstracted telemetry from all of those devices, from all those vendors the exact same way. And you can build high-value integrations above the SDK in order to integrate either to your existing back office or for our controller vendor partners to enhance your commercial value, gaining access to 24 platforms that otherwise might not be possible in your catalog. So we wanted to have all of that happen and do so also at a very high scale. So we wanted to support, as I mentioned earlier, maybe small deployments for certain premises, like maybe hospitality, maybe we're only talking about a few hundred access points, but we also wanted a tier 1 CSP to feel equally at home in Open Wi-Fi and be able to put this as a first-class citizen in their back office, integrated at scale, doing hundreds of thousands of APs under management. Entirely possible with Open Wi-Fi's design. Part of the how do you ensure things are running smoothly is also solve some of the most common problems, like what version of firmware am I running? That really shouldn't be a chore. Why don't we just have that as one of the microservices in the SDK that allow you to trigger when firmware management happens? There was a great conversation that just happened in the last day or two that said, hey, this would be neat, feature for Open Wi-Fi. What if we wanted to roll out a firmware upgrade, but we'd like to drain subscribers off of the access point before hitting the firmware upgrade? I won't say who asked that yet until they choose to announce that in one of the TIP OpenWiFi calls or talk about that feature among the community. But it's a great example of how when community begins to expand their use cases and reliance on OpenWiFi, these really cool, right, design ideas come out. And so there's already members of the team thinking like, oh yeah, of course. Yeah, we can just augment when we call the API to the FMS service based on knowing the current state of how many attached UEs are on the device we want to upgrade. And how do you get at all of that? Through the common APIs that are available in the SDK. So it's a very fine piece of business logic, and it's all possible by the interfaces we already expose, right? We'll talk about the art of the possible. This would have been much more on message if we could do the live demos, but we brought a lot of functionality into some of the user interfaces of Open Wi-Fi, so I hope folks will come up to the meta booth on days 2 and 3. I'll be hanging out on a side area, able to do one-on-one or group demos for the actual TIP Open Wi-Fi SDK stack with a live system with a lot of devices connected. But we really wanted to show, again, that art of the possible moment. You can run a network today on the open source stack if you wish, right? Entirely possible. But we don't show you everything. So you really do need to look at the open API spec for our northbound interface. You need to look at the device data model for uCentral to truly appreciate how many total features there are in Open Wi-Fi. Because again, we have tremendous vendors in our community, and we want them to have commercial value in their platforms and products. So there's a lot that you'll see, certainly when we do UI demos and such. Again, please come on upstairs. But it's certainly by no means not everything that's available in Open Wi-Fi, right? Our vendors, partners, they bring all that value. Okay, so it's supposed to be a developer stack. So we're going to start showing things that look like terminal screens and outputs. It's going to be fun. So these are the names of the actual services. You'll see things like OWSec, OW Gateway. And if we just jump back, we see these sort of in more plain language here. We have the UI service, we have the provisioning service, analytics service, firmware, security, and gateway. So we're going to dive into a little bit of what each one of those do. Some of them are plainly named. You can guess what they do. But they sort of work together in concert in a way that's special. So OWSec, this is the security service. OWSec is really the way in which you're challenged both from inter-service so talking horizontally among microservices, as well as northbound, right? To be able to obtain a bearer token to have access to the APIs themselves, you have to talk through OWSEC. Once you have the bearer token, you're able to then access long-held data that's in the database. You're able to make on-demand calls through the OpenWiFi gateway direct to the serial number of an active device on the end of a WebSocket. So a great example of that is, and they're in the room, so there's a very common use case. You have a WLAN controller, you've got a very rich dashboard, and you're looking to make a troubleshooting diagnostic view come alive on the screen in front of you. So how would you do that in OpenWiFi? I already have a controller, it manages my devices, but I've decided to add OpenWiFi devices. No problem. That's an on-demand API call for active device stats. We have an API endpoint just for that purpose. So in the troubleshooting and diagnostic screen of your controller, you would specifically make that call to the OWSEC service. Say, I need a bearer token, please. These are my credentials to gain access to the SDK. Once you succeed, you hold that token for its lifetime. While you hold that token, you then make the on-demand call, specifying the device serial number, and as well what interval you want the data to come back on. It'll default to, if memory serves, 3 seconds, and I think you can also pass how long you want the data to return back. So you can say every 3 seconds for 60 seconds. You could even say every second for 5 minutes. Depends what you want to do. Remember, you're making an on-demand call. On-demand implies cost. So you're starting out from your controller, you're going into the SDK gateway through the northbound API, you've been secured, you're then saying for this particular device, you would go down over the active web socket that's fully encrypted and ask the uCentral agent in that device, give me all of your stats. So everything that's coming off of the bus right now, send it right all the way back up to my WLAN controller. On-demand call, troubleshooting screen, works like a charm. Let's say that you are not interested in that troubleshooting data. What you're really interested in is sort of more trend data. How's the health of my Wi-Fi network been from, again, the perspective of my WLAN controller? Well, that's more long-held data that is based on telemetry. And where does telemetry live? In Kafka. So you have a consumer then of the Kafka topics for all of the event and the state data into your WLAN controller environment, where you can then choose to persist that in your own unique way. You may already have maybe a time series database format that you normalize to, maybe have other columnar database decisions in your own architecture. So you can have a consumer in your WLAN controller to the Kafka bus for the topics that contain state and telemetry data, event data and state data, and then bring that into your environment and it'll show up as native to your UI. So if you're a controller partner that's integrating OpenWiFi, those are some common examples of how you would get there. So the OW gateway, OpenWiFi gateway, we specifically called attention to that a couple of slides ago. Again, that's the northbound to southbound actor. And at a minimum, there's not too much other than the OpenWiFi gateway and the OpenWiFi security service that you need to actually get going with OpenWiFi, other than having an OpenWiFi device. That's kind of the main core. So if you had your own WLAN controller and you're looking to integrate, you need to make API calls to the OW gateway through the security service. You need to consume topics off the bus. If you have a mature product that does all the other things, like firmware management and user dashboards, field technician tools, and so forth, you're already good to go because you have access to the data that you need and you don't need any of the other microservices from TIP potentially. However, we seek to obtain a broad base of users. So we have additional services here like the FMS service, firmware management service. We'll talk when we get into the CI pipeline, or again, we like to use this catchy term, DevOps for Wi-Fi. When we do nightly builds of images, they go through the CI stages and they end up being published into a repository that syncs up with the FMS service. So at any time you've deployed OpenWiFi, you look at your dashboard of devices, either through API or through UI. you can always choose to upgrade them to the latest release candidate image or even the latest development image. And it's already been synchronized for you in the background. So you can also look at that and say, I like the FMS service, but I don't like any of its business logic. You can write your own business logic around how you control firmware out to your field. Again, the API defines what you can have access to. OWPROV. So we worked with an operator who, well, they were looking for freedom of choice. They had two of the, you can guess, tier 1 WLAN equipment vendors in production today, and they're a worldwide operator, super cool team. And they said, if we had, they really only said looking at OpenWiFi, if we had like 8 or 9 more things, we can actually deploy this from a vertical integration perspective. We're a large operator, we have our own teams, and so, if we just had a half a dozen or so more features in the stack, this would be good enough for us to displace some pretty large incumbent platforms. So we should, sure, to do what you're asking, you really are looking to solve some provisioning type challenges. So I should back up for a second. When you want to provision a device, at the base level, you're sending that payload of configured data model parameters that get unwrapped by the device, as we discussed. But you can really write your own provisioning. The creation of what that per device configuration file looks like is basically the creation of a syntactically correct JSON document for the device that you're looking to configure. How you create that set of keys and values is entirely within your own development span of control. You could manually create it, like many of the development team have done when we were in the early days of building out uCentral. We created the gateway and the security service, and that was all we had. And so we didn't have any way of doing provisioning at scale. You would manually create your configuration files. You would send those through a post or a put API endpoint on the gateway, and that was it. You use those endpoints, you said what your UID was, which was the device serial number, and away it goes. And the things that we said we would do, we did. We validated that it was the syntactically correct to the data model, and we verified that it was compatible inside the device. And we sent back error code 0, 1, or 2 accordingly. All was good. But that might not suit all. And so if you wanted to provision at scale, maybe do venue-based provisioning. Think of a facility like IFEMA here. There's like 4 or 5 levels. There's a lot of different rooms, maybe a lot of different types of tenants, a lot of different types of roaming needs, maybe different network topology needs. And you probably want to do that in a way that doesn't end up creating an individual configuration file per device. You probably want to create a template that says, well, these are my global parameters, maybe for security and telemetry, things that should always be present in every device, no matter which device it is. And then I want to create a venue for floor 0 in IFEMA, a venue for floor 1, a venue for floor 2, maybe a venue just for the Berlin room that we're in right now. Because I want, as I get more close to the edge, I want more specific configuration template values to be applied. And so we built that out in the OpenWiFi provisioning service, which has effectively a series of templates with weighted order inheritance. So devices are made to belong to an entity. The entity can have child venues. And entities and venues can associate to resources. Resources can include device configuration templates, which then are bundled together and processed out to the ultimate configuration that goes to the device. Entities and venues can also inherit resources that you just don't want human error to be repeating, such as your radius server or radius proxy information. And so you can say, anytime I define a hotspot, no matter where it goes, it globally inherits the hotspot authentication for all of IFEMA. And you never have to enter that anywhere else in the system, right? It's just done for you. So those things we did in the OpenWiFi provisioning service, that's probably the place where when we do live demos, people are the most intrigued. And indeed, this tier 1 operator, once they saw the provisioning service, went, yeah, we could deploy that in production and support it themselves. OW Analytics, this was actually part of that same operator ask. So for any of the developers that are in the room, you might be thinking, it sounds like a lot of data that's in flight, and you wouldn't be wrong. Obviously, we're sending things like LLDP information, client stat information. We can send DHCP snooping data. We send all the 802.11 management frames up to the gateway to be broken out and pushed in as normalized Kafka topics. So it's a tremendous amount of data. What could you do with that? Well, it's not all that valuable unless you can correlate it to, let's say, a venue. So I'll pick on IFEMA again and just say, I'm interested in how many roaming DOF events happened on floor 0 between 9 and 12 a.m. this week. Well, we have that data. The question is, right, how do you make it relevant to a venue from the perspective of provisioning and building out intelligent dashboards? The provisioning service added dashboards just for that. There's a series of nicely done React tiles, and they'll display total APs in the venue. They'll give you their uptime, their memory load, live view of the number of subscribers, and there's a per UE set of information that returns back MCS, uplink and downlink, error stat packets, all of the MSDU information that you may never wish you asked for, but it's there. All of this is returned then through the view that the provisioning service can use because OpenWiFi Analytics Service is doing that correlation data for you by consuming all of that out of the bus and then presenting it in a way over the APIs to the provisioning service. So it looks like a consumer of Kafka topics and a horizontal API supplier to the provisioning service. Okay. OpenWiFi subscriber service. I know from, yes, Chen, please.
On the APIs, is there a way to filter those APIs at the AP level itself, or you have to subscribe to all of the information?
Just a quick question there. Can you filter down the stats that you want at the AP level itself so that you don't get bombarded by a lot of stats, or do you have to consume all of it and then filter it in the cloud? Can you speak a little bit on that?
Yeah, great question. So I think it depends on the question you're trying to ask. So what I mean by that is, to the earlier example, am I troubleshooting right now? Do I need live data now? Because I maybe have a customer agent who's trying to walk through somebody's connection troubles right in the Berlin room here at IFEMA. Then you would make an API direct call and you would ask for all data to be returned. Remember though the comment that that's a very expensive call. And so it places a load. It's not that much of a load on the gateway, but it is a load on the device. Certainly, right? You're asking it to essentially copy everything that it's getting off the bus for events and all of its state information. You're asking it to send it at the interval that you passed in that on-demand endpoint call. You may have said every second. That's a valid ask. So if you're trying to answer that problem, there's a way to do it over the API, and it would make sense to do it that way. But you also wouldn't have that as a long-lived experience. It'd be like that maybe for a few minutes while the agent is looking at the screen and then they move on. When they close that screen, or when the screen behind the scenes close the connection, then that cost goes away. And the AP is still doing its normal telemetry work, which as part of the device provisioned information set what the interval was. Usually it's maybe 1 minute, maybe 5 minutes that it's going to send telemetry up to the gateway. So that more longer held data you would subscribe to as topics from Kafka to obtain. And you build your experience of that from consuming the topic data. Yeah. Which is actually an interesting way to segue the OpenWiFi subscriber service. So we're pretty open, obviously, about all the data that you can obtain. What if you wanted to have an end user subscriber app? So I, the end user, want to be able to manage my own connection. This came up from a few requests in the project group. A lot of folks interested in solving for MDU deployment use cases. And so a lot of times there's a real mismatch in the industry when you look at trying to solve managed Wi-Fi service and managed service in general for MDUs. You go to the residential side of Wi-Fi and you end up with home gateways. And they'll typically be broadband form-based devices. That's great. Maybe they're Ethernet, like gigabit Ethernet WAN devices. That could be. But they don't necessarily plug into a convenient solution that the building owner, the property owner, is able to easily manage necessarily. The property owners usually also want, in addition to what's inside the customer's premises, they also want to have amenity networks for the building. IoT sensors, security cameras, door readers, environmentals, so forth, maybe common area Wi-Fi service, the ability for tenants to roam around their building, right? Have seamless multi-AP, multi-shared Wi-Fi roaming experiences. Whether you're in your apartment or whether you're in the laundry room, the Wi-Fi always works. Those are features and experiences that only come from the enterprise managed WLAN space. Right? Everyone here in this room probably knows where they can think about with their existing vendor, they can get those features out of their enterprise access point. That's typically mounted on a ceiling, right? It's not sitting on the desk. OpenWiFi suggests that, well, you could do subscriber-based Wi-Fi management, but you need to protect how they get to the data, and you need to create a one-to-one view of the subscriber to the devices that are being managed to that subscriber. So OpenWiFi subscriber service is a simple microservice that creates one endpoint to abstract all of the behind-the-scenes access to different data in the SDK so that your subscriber app is able to look at one device treated like a gateway, and you as the end user can say, oh, I'd like to change my SSID, I'd like to change my password, encryption method, I'd like to see the active devices, what's their signal quality health, I'd like to block the following devices, all of the things that you would normally expect out of a residential type experience, but it's the same common platform. So imagine if you're the MDU operator, property owner, or a managed service provider to property owners, and now you have access to 24 Wi-Fi platforms of a variety of indoor and outdoor and all sorts of different Wi-Fi generations at your disposal, and one common cloud stack that allows you to do all of the in-building amenity networks, hotspot networks, as well as support for end subscriber management for their own individual devices. Important to note that while the subscriber service enables that conversation to be possible for any of the apps that might be consuming it, it doesn't negate or remove your ability as the operator or management partner to that network of continuing to manage those devices. One of the common asks was, could we have a tertiary Wi-Fi network in the customer's home alongside the rest of our common area networks in the MDU? And the answer is, of course, yes. Even though the subscriber has the OW sub-based app and they can change their SSID and do their configuration changes, as an operator, right, or as a vendor of a stack, you can still permit management of additional networks inside that customer premises as well. That comes up a lot, I think, because of, frankly, we did an awful lot in OpenWiFi to help make open roaming fantastic in open source. And a lot of operators are saying, like, we could do a tremendous mobile offload conversation in all these MDUs if the Wi-Fi would always just work. And because we made open roaming a priority in open Wi-Fi, you can push an open roaming SSID in the hallway AP, in the laundry room AP, in the courtyard AP, and in the home AP. And we'll all just work. Oh, let's talk about the cloud. We're still talking about the cloud. Yes, there's a question, please. I love that question. So the question is, does Orion work on open Wi-Fi? So that is, I'm trying to recall which of the PG calls it was recently. It might have been in September's PG call. So we highlighted in September's call that we had done a full interop and test setup with Orion. And we indicated back in, I'm going to say May or April this year, that we were going to start that integration. So we had a successful outcome there. Google Orion works out of the box with open Wi-Fi. Yeah, that's a great question. So if we look at the cloud, so let's take a UI tour briefly. We won't be able to take that UI tour briefly, but again, come on by the Meta booth. We'll be able to give you some show and tell time. We'll talk a little bit more in detail about each one of these microservices as to what we mean by decoupled, but fundamentally what we're talking about is they hold no state. And to that end, what we mean is you could kill a running microservice and replace it with a new version, and it would pick up where it left off. Because you're calling out to an independent database, you're sending to an independent message bus, right? You have managed state. You're not holding that inside the microservice. That also means topics like horizontal scale become quite easy. Topics like running in any cloud native environment any public cloud become easy? So these are all pretty important topics we'll talk in the next 2 slides about. The aspect of this, you'll see there's a pattern, right? So every microservice has a northbound API, and we'll show what we mean by that in a moment. Every microservice has a reference publisher interface to essentially send its data to Kafka. And then the ORM talks to SQL backend. So all microservices effectively look the same. And here's that call out to the RRM microservice that the Meta Connectivity team delivered. And ooh, look at that. There's an extra database. And nobody noticed. So I mentioned earlier at the start that Postgres just lives, or SQLite if you don't enable it, by default. So all of the SDK will just happily carry on and connect up to Postgres. If you add, and this is all done through, if you're in either Docker Compose or if you're in Helm charts, this is just done by turning on or off the option to deploy to one database or the other. The same thing happens when you choose to deploy the OpenWiFi RRM services. You'll see in the Helm charts for that it turns around and pulls in a MySQL database. From your perspective of integration, northbound terms, you have no idea that's happened. Right? Long-held data of the RRM microservice, the business logic the RRM microservices are doing, are dependent on that data, right? But you don't need to care. And that's a fundamental principle of a cloud-native design. So you end up with multiple databases, which also means you're able to change persistence layers in the back end later on. If somebody wanted to move this onto, a Mongo environment, totally possible, right? You change the ORM logic, you wouldn't change the application, right? So again, that's part of doing microservices as best as we can. So all of those services look the same. They're all deployed through automation. And this is this philosophy, native horizontal scale. All of those microservices that we saw are basically optional, other than, as mentioned earlier, you need the OWSEC service, that's your northbound, and you need the gateway if you're going to talk to a device southbound. After that, pretty much everything else is a la carte. Again, you're an existing controller vendor, you have the ability to do provisioning or assurance or otherwise, then you don't need the provisioning service and you don't need the analytics service because you're consuming the plumbing. You want to focus on the plumbing, right? You don't want to reinvent the plumbing, and the SDK is the fastest way to get there. You don't want to have to do that engineering twice. The other aspect of the cloud-native design, and folks might be familiar with this. It's a well-proven pattern for a few years now in the industry. You can check out the 12-factor manifesto online. It talks about what you should do when you do a well-designed microservice. But fundamentally, this is all about black boxing business logic at the end of the day. I mentioned how excited I got a second ago when the RRM team contributed their microservice, and it's written in Java. The other microservices are written in C++. Ta-da, we have a polyglot. Again, no one knows, because you don't have to. It's a black box. Just respect the interface. And so we'll talk about OpenAPI in a quick second on that front. The other thing that's kind of important in microservices is you always want their role to be singular. Never ask one microservice to do too many things. Right? Don't ask the pizza delivery person to change your roof. That wouldn't be, they both come to your house, but they're two very different things, and you're probably not going to get a good outcome one way. It's either going to be cold pizza or it's going to be a pepperoni roof shingle. So you really should keep the microservices to the purpose they're meant for, and that way they remain relatively small from a development standpoint. So each sprint, you should have the ability to refactor the entire microservice. In theory, and this is the dream, if you take, let's say, maybe the OW Analytics service, and you say, I get it, it was written in C++, that's great, but I like Golang. There should be just enough and only enough in the analytics service that a developer could take the pattern that's present in C++ code and implement the exact same thing in Golang in one sprint. Or either developer refactor those entire services in one sprint. Because again, they're focused on doing that one thing and one thing well. And if you need to do more than one thing, that's another microservice that you add. So each microservice is going to have a few fundamental tenets. They need to connect to databases. That's the ORM. They need to consume the service events topic in Kafka. That's how service discovery works. And so when you look at the OpenWiFi dashboard or you use the API to list the discovered microservices, they'll return all of that information, every microservice, what version they are, what dependencies they have, they're all listed. That's because we use the Kafka bus as essentially a listener to that discovery. We need to obviously participate in OWSEC, so you're going to have HTTPS happening in your microservice, and you're going to obtain a bearer token for all of your inter-service API calls, which you're then going to be talking over, talking to provisioning, talking to the gateway. You're going to be looking at having on-demand actions to devices maybe, or you're going to be looking to update provisioning values for a venue. All of these are inter-service API calls. And Kafka. In theory, you could change Kafka to something else. That's also possible. But you need to change the pub side of all the microservices therein. So how do these APIs come together? We follow sort of a strict pattern of being Open API version 3 compliant. And this means essentially these endpoints are self-describing. They also have a common level of standard to them. We have the ability inside the microservice to talk about the horizontal conversation. You can run those without SSL if you wish. It's certainly a possibility. And then, at the end of the day, all interfaces should be versioned, always. And so that's something that's enforced when we do linting on this. If you want to look at the OpenWiFi Gateways Service API, we publish that obviously in the OW Gateway YAML, and then the design standards are listed, for example, in our protocol specs. So check those out on the TIP GitHub repos. You get a sort of a full view of what's done through our view of compliant Open API. And so we kind of describe this in good detail. This is actually taken right out of the design standards markdown. So when we look at this markdown, we talk about what does any microservice need to do in terms of presenting itself to inter-service calls, the event types that are supported, and how you can consume, put and post data back and forth between services. And we provide this CLI, which this is a real eye chart. So I'm going to say there's a test later. You can't get any of the free food that's available outside unless you can name 3 of the CLI commands. No, that's just not true. Not true. The CLI exists. You'll find this in the OpenWiFi Gateway Service repo, and the CLI exists essentially as, again, it's sort of a blueprint, art of the possible. Doesn't implement every possible CLI function, but it does demonstrate to the developer how you can make those calls to the API. It's a great way to actually work on incremental features. Always start by the test case, be test driven, but write the CLI for your new feature. Contribute that to OpenWiFi. Then, right, maybe work on a UI. Maybe it's your own UI because you're a vendor. That's cool. But if you put the CLI in, then you got a nice, both API and CLI framework test available to you. That's kind of neat. So there's a lot of functionality that's existing in here. You can actually provision, restart, upgrade firmware, factory reset devices, all through the CLI that comes out of the box. Some of the interesting commands here, the conversation earlier about what are some of the things we can send on demand and return data from. Wi-Fi scanning, treating APs like probes, if you will, in the network. You can expose all that through the CLI, obviously because it's just calling the API. So anything that you might use through curl or Postman or something built into your IDE, as soon as you're following that API that we described earlier, give it to the CLI. It's just a pipe out of the same data. So again, it's an eye chart. There'll be a test later. So listing all devices. And so this is the literal curl command in order to tell me every device that's active against the gateway. And so you'll return back this JSON payload document that you parse through it. You'll get all the data that you asked for. So talking about microservices, we sort of talked, I think, over and through this already thus far. Isn't this great? We got a visualization, one visualization anyway. So this is a view from from any one of the services that are in the SDK today. You can look again. We talked about that subscribing to the service discovery topic in Kafka. So this is the data that's coming out of Kafka. What's on this screen grab that nobody in the room can see right now. And what's in this is every single microservice. We've got the analytics service, the FMS service, everything's there. And it includes what version of Linux they're running on. Those are all Docker containers, Debian instances, right? It includes what version of the service. And so is it 2.7, is it 2.8, is it 2.5? Folks familiar with OpenWiFi know what those mean. Those are releases of OpenWiFi. And so you can see all of these services, and they don't need to be one language. They're multiple languages. So there's Java services in there today. There's C++ services in there today. We talk about the horizontal scale nature of the design. We have a load simulator that was written in Erlang. It's a developer session, so I'll ask the question. I don't know if I'll get any hands up. Anybody here know what Erlang is? I got a nod. Awesome. I got another, yeah. Okay. Somebody wanted to have fun. They had an itch that could only be scratched using Erlang, so they did. So the OpenWiFi load simulator was written in Erlang. Again, it's available from the TIP repos. It's available as open source, and you can generate a tremendous amount of load to the gateway using the OWL's OpenWiFi load simulator. And it, again, participates in the same discovery bus, so it shows up as an available service. So message bus uses, we've kind of talked over those as well. And again, this is how you're decoupling a lot of maybe time series information or just longer held data that you're interested in, maybe for assurance reasons. So the events get pushed up into Kafka. Each microservice can essentially post more information that's relevant to its function, right? So obviously then you get a richer and richer sense the more you build out functionality on the stack. We have, obviously through each microservice, you have a public and you have a private endpoint. So the private endpoints, I mentioned earlier, you don't have to be HTTPS inside your cluster, right? Because we separate the endpoints intelligently. But there's the ability to run at a very high interval rate, or meaning very low interval rate. It all depends on how verbose and how often you want the data. And then this is just a snippet of a bit of telemetry that's sent from a device that, this is a device passing up over the WebSocket. The gateway is taking this message, and then it's normalizing that into a blob that gets pushed onto Kafka. So as a consumer, you might be interested in some of the pertinent information that's inside of this, like probably, see, I'm close to the screen and I can barely read it, so this is a great thing. So I can see what HT supported rates are, and I can see MCS set information. Most interestingly, I can see the signal level. So, I see a probe request at the top. Yeah, okay, cool. So here's a probe request that's come in, and you get the available information from capabilities, the MCS set, and what the noise floor was of that, or what the noise of that probe was. This is cool, because anybody who's familiar with things like U-steer, that probes are pretty important to determine whether or not we care about allowing the device to even join the AP, or we're going to silently ignore it because its signal isn't strong enough. We want to maintain a minimum amount of bandwidth quality. So imagine if you have a whole bunch of clients that are showing up into the edge of your network, and they're failing, let's say, the U-steer local RRM minimum signal strength, because after a certain level, you won't have the right MCS. It's a poor bandwidth connection. We just don't want that for our brand. Okay, great. How did that start? It started right here in this type of message, right? This message would tell you at the NOC level or at the controller level, right? If you're building out, a vendor controller platform, this data presented as a bus topic you consume is going to give you that view of we were silently ignoring some percentage of the devices that maybe are in the third level of the IFEMA building in the Berlin room, simply because none of them had a strong enough connection to win. And from that, you can build very intuitive logic, again, focusing on the higher commercial value. You can build business intuition in your controller platform that says, there's probably an infill problem in that location of the venue. What if we add another access point? And all of a sudden, you'd see the rate of these messages that are being silently discarded go away. So again, the message bus is your friend, and you can build an awful lot of solid business logic off of it. Oh, and that's one full message. Isn't that great? Everyone's going to take that home. Print this out. This is so fun. So fun. Everyone, no, okay. So this is one single statistics message that's got a reasonable amount of information present in it. So obviously this is compressed. I think it's like a 6 or 8 times compression that comes up the telemetry path, John. And then, again, we normalize this and publish it into Kafka. We talked about data persistence earlier as well. As mentioned, by default, if you do nothing and just deploy straight from the repos, you'll end up with a SQLite binary embedded database. It's meant for, well, it's meant for any amount of data less than 4 gig if you read SQLite's developer site. But more often, this is your lab environment, something that you're looking to just do quick experiments with. You don't have the high availability Postgres information available, whatever the case may be. Less than 200 devices, you're fine for a good amount of time. You want to actually go into production, uncomment the PGSQL HA commit lines for the Docker Compose or for the Helm charts for running in Kubernetes, and then you'll be up in a proper cluster. I should also mention that from a schema perspective, we handle this in the service. So alter tables that need to go in from one version of service to the next, we take care of handling that state change, or that table change, I should say, between versions. If there's a new dependency for data structure, we'll change the schema in the database as we do the lift in the microservice. Favorite topic, scale. Who doesn't want more Wi-Fi? So this is kind of all building up to the idea that we talked a lot about microservices, we talked about decoupling, we talked about how you consume data that's either expensive or non-expensive. And it all is built around this idea that you could be a very small deployment of, let's say, 200 APs, or you could be a significant deployment of 200,000 APs. The exact same cloud structure should support either use case and anything in between or more. And how is that done? So because we talked about the OpenWiFi load simulator, if anyone's attending the dev calls or the PG calls, you'll know that when we do a release, so quarterly we do releases, 2.7, for example, just released in September. Every single release of OpenWiFi goes through a scale test. We use the OpenWiFi load simulator. Test that against a single gateway instance. 25,000 APs are injected, and the gateway is required to provision all 25,000. I think we burned something like 112 seconds, and all 25,000 are provisioned. So we're pretty happy about those response times. But you can keep going. So we do 25,000 in a single gateway microservice when we do these release tests. But there's nothing stopping from the conversation of deploying in production, various other ways of looking at load. We consume about 3 gigs of memory and not a whole lot of CPU, certainly not in the long run. In the immediate burst perspective, yes. But in the long run, the gateway is sitting there, 3% CPU on average. 25,000 devices looks like about 3 gig of memory. So in a reasonably well-equipped system, you can take that gateway up to many, many more devices. But there's always puts and takes. So you would want to balance, is the gateway responsible for devices that are not sending telemetry every 60 seconds? So remember, the gateway's got an active role in all data coming up the WebSocket. So if the deployment only needs 15 minutes, 1 hour, so the devices are spreading out their interval of sending telemetry on an hourly basis or a quarter-hourly basis, you may not need more than one gateway if you're serving 100,000 devices in production. Entirely possible. But if you said, I've got 100,000 APs that I'm looking to manage, and I want stats every minute, well, that'll change the load factor on balance for the gateway service relative to your deployment size. You may want to have additional gateways just for both performance as well as surety that should there be any outage, you already have another gateway available that's going to take the next call. So again, because there's no state between the services, you can put in a front-end load balancer and there's no issue with that at all. The front-end load balancer becomes the actor that then holds the TIP signed key. So that devices, their SSL gets terminated at the load balancer now, not directly at the gateway. And again, with no state, the load balancer is now moving across any number of OpenWiFi gateway services that you have in your cloud. So opportunity to scale is quite great. This is the fun part. So DevOps for Wi-Fi, I keep saying that word. So you can think of, and John's going to talk about this in great detail, you can think of how TIP built out OpenWiFi really as a well-curated version of OpenWRT that was made with all of the advanced enterprise features that you would expect, including a completely re-envisioned data plane, a lot of different overlay network topology support, very high-scale mesh support. There's a lot of stuff that went into that. So to do that in a way that doesn't cause a moment-in-time fork with the operating system as well, lets developers be able to work on just their incremental feature as a patch and contribute that easily. We set up this build tree environment, WLAN AP. It looks like the text got cut off, but if developers are in the room that are familiar, you'll know you're inside TIP's Git repo. WLAN AP is where all of the firmware gets built out. When you're in there, that WLAN AP, or if you're in any of the WLAN-cloud repos, they all basically look the same from a CI perspective. We take in all the commits that come in through pull requests. When we merge those will end up going into a nightly build. The GitHub actions are our friend. We collect all those artifacts up. We build the resultant binaries, whether it's a device or whether it's a Docker container. So those will happen nightly, and they show up then in the artifact repo, and they're synchronized out to whether it's going out to ultimately S3 for device firmware images, or if it's sitting in TIP's GitHub because it's some other use case such as the load simulator. All of this is happening through the nightly build tree. I'll leave the way in which the firmware images are built to John specifically talk to, but there are. Well, I think there's more than 24 different profiles today. There's just some that are not built nightly, is the other way to say that. So if you're looking through the code repo and you're looking at the build environment, you'll see that there's a difference between the number of profiles and what's actually built nightly. And there's just various reasons for that as far as what the community has a priority for having in nightly builds. And this also gives us a great flexibility as to, when you contribute a patch, you end up being able to possibly realize that patch inside of a 24-hour window. That's an entirely possible outcome. And so if the latest, Samsung TV just showed up in the nearest electronics store wherever you live, and it has some feature like, Wi-Fi Direct, and it never used to exist, but now it does. From a community perspective, anyone who contributes Wi-Fi Direct functionality into the stack, the entire community 24 hours later potentially could be testing that against that brand new TV that's just shown up with this new Wi-Fi feature. And that, I think, is one of the most important engineering superpowers of OpenWiFi, is that there isn't an existing vendor in an existing vertical stack that can really move at that type of velocity. So that's a real unlocking power for TIP. So we kind of follow what I think it's fair to say what the Linux kernel world follows. You'll see this in OpenWRT, and we just apply the same, whether it's a Docker container for a cloud microservice or it's a device firmware image. So we look at a staging, next, main, and release with major and minor versions included. If you're looking at our trees, you'll see tags when we do a release candidate. So for example, 2.7 had RC1, RC2, right? And so obviously when you go into soak testing, you'll find something during the release window. It'll get patched, and then there'll be an RC2. How'd that patch happen? It happened from that previous image where we created a branch, we fixed whatever the issue was, we contributed as a patch, and then we merged the patch in, we do another soak test, it passes, we'll tag that as an RC2 or RCN, right? Long-held development, so things that are happening inside a monthly sprint, for example, or sometimes work that's going on for multiple sprints, could be in a staging tree for that amount of time, experimental features and so forth. Anything that we do in TIP terms, while we do all of these builds nightly, and we produce these binary outputs nightly, all of the setup here is easily cloned and brought into your own individual environment. There's nothing that we do that has any dependency that's private to TIP. You can all build inside your own environments. And that's for many operators or many vendors, that's a huge requirement to be able to know that you can satisfy dependency management if you're going to depend on software that you're commercially selling. So you can go direct to source and TIP, or you can also bring into your own and work locally and then contribute back up. So I sort of hinted at the CI process a second ago. These are the workflows, these are the GitHub action environments that are at play. So when this gets kicked off, again, whether it's a device or whether it's a Docker container, all these flows will be essentially described as an individual YAML runtime. So these runner scripts are going to go off and build, an Indio device X, a CIG device Y, an edge core device Z, and so forth. And you'll be able to see those status outcomes. We know right away, did a build pass or fail, right? But we also know right away whether the functions in that build pass or fail, because we actually test that through the TIP Fremont OpenWiFi lab, where we take the outputs of these builds. So the CI process next step is, all the binaries exist. The next thing that TIP does is it picks these up through QA automation and executes around 3,244. I'm not sure if it's the next slide that comes out, but over 3,200 nightly tests get executed across a couple of dozen RF chamber environments. And so it's a pretty powerful statement of trying to stand behind the quality of the open source that's in the community. And then last but not least, where it's synced over to S3, that's where the device firmware lives. And then, of course, from JFrog direct is where the Docker files are going to live for any of the WLAN cloud services. And then here's a fun GitHub in action. It's great. We've got some screens, animations. On the right side is obviously the action runner scripts. On the left side is essentially the JFrog output. So JFrog, that is the artifact store, first stage artifact store, essentially. And we push from there for any of the WLAN AP device images. We also host from there any of the Docker images. So the testing story mentioned just a second ago, we're super proud of this. Again, we've got a couple of dozen RF chambers. They're all running LandForge from Candelatech. The WLAN testing repo in TIP's Git is where you'll find all of that test automation code. So again, talking about dependencies, there is nothing that prevents any partner in the ecosystem from running the exact same test automation for themselves. Yes, there's a dependency on there being a Candelatech LandForge system, but other than that, we automated the entire environment of 3,200 plus test cases. And so if you clone the WLAN testing repo and apply it into a local environment where you may have maybe just one chamber, or maybe you have multiple, you'll see the PyTest framework that we have. It's all easily adjustable to your local environment. Or you can also look at any of the dashboards that are produced out of the nightly builds. All of this is open and exposed. And so each one of these scenarios, whether it's Wi-Fi 5, Wi-Fi 6, 6E, or MDU chamber setups with advanced topologies based on those types of deployments, they're all exemplified through the baseline testing that happens in that nightly automation scenario. So talking a little bit about the solutioning that goes in, just checking on our time, a little bit off. So each night, again, those pull requests come down, they get built as images, and the test automation suite fires up. What we want to do is also spin up the cloud SDK at a specific pointed version. So each chamber gets its own SDK. That's another important point. We test the whole stack. We don't just test the device, we test it as a system. And so if we're looking to test 2.7 in September and we're looking to test the same AP version, we're doing everything at the same time. So we spin up a stack, we spin up an AP in a chamber, away we go. And then the outcomes, again, all the test suites are going to be published. All of the automation that exists here relies on the exact same automation that we use as part of the development. So if you're looking to deploy into AWS on Kubernetes, we have our test suites using that exact same Helm chart to do the deployment for the test environment. Folks that are used to the developer work calls, you'll know that there's a QA instance and a dev instance that are alive all the time for TIP, and those get deployed using the exact same Helm charts. Like we completely dog food ourselves always, right? So from that standpoint, dev and QA instances exist. There's even, if you wanted to, you could stand up a virtual AP image, which is an x86 build of effectively an OpenWiFi WRT image. So all this is possible, again, with the exact same automation tooling. There we go, there's the real number, 3,474. So at the time this slide was made, 3,474 PyTests exist for automation across Wi-Fi 5, 6, 6E, in all those scenarios, single chamber, multi-chamber. You're testing for not just the features of Open Wi-Fi, but you're also testing for general Wi-Fi operation, performance and conformance in 802.11 terms. The nature of the LAN/FORT systems gives us the ability to inject heavy client loads. So we'll run commonly 250 UEs up against an access point. We'll inject variable types of traffic, ensure things like the message that we receive in telemetry looks right based on there being 250 UEs coming in from that device. So all of this is done through the test framework, is fully automated. And again, we do it nightly, and then we do it quite specifically for each one of the release candidate images, where we turn the OWL system on and we put 25,000 devices in. And we say, go for it, let's make sure it still runs. And this is a neat system. So one of the community members, Quali, as you can imagine, we have this open source community lab for TIP. If you've got 24 chambers, that sounds like something that too could be automated. Okay, you can reserve chambers and use the Quali tool to be able to say, I'd like to run a specific test. Could I use the MDU chamber, let's say Friday evening from 8 to 10 p.m. Pacific time? Entirely possible. The dev teams will use the Quali system. Certainly our test partners at Candela Tech and elsewhere in the community will use the Quali system. In fact, all of our PyTest automation makes its calls through Quali in order to make sure that the chamber is set up to a normalized set of baseline conditions before running the test. So this is a pretty neat system. Encourage you to check that out if you're looking to set up anything locally yourself. As mentioned, everything is public. We don't hide anything, the good and the bad. I think as the page moves around here, you'll see that some dials have more red than green. It happens. And so every night, the Allure system is producing out what's the rendering of the completion state of all that PyTest automation, the 3400 that ran. And so you can see why something failed by drilling down into what part of the test case when it was run, what part failed specifically. That's what we're seeing with these red explanations. But the summary view is up on those dashboard dials if it goes back to in a second. Let me just see if we can get us back. There we go. So each one of the community members agrees that if their device is in the TIP lab, it's going to be public, right? Is it working great? Are there problems? Everybody will know. And by the time we get to a release candidate, all the dials must be green. Otherwise, we'll hold the release, fix what the issue is, and move on. And there's no live demo, as we keep saying. So folks, again, upstairs across from the meta booth, we'll set up day 2 and 3. We'll hang out. We'll be able to do a whole bunch of walkthroughs for the UI and in a lot of different types of operator deployment scenarios or integration scenarios or conversations about how you as a vendor might be interested in consuming the stack, integrating with the stack, or you as an operator might be interested in deploying either with one of our controller partners who have consumed the stack or possibly deploy the stack directly yourself. All these and probably a variety of things in between are possible, certainly with Open Wi-Fi. So I think with that, we transition over to John, and John will guide us through. We have a question. John will guide us through the embedded firmware development side, but we have a question before we break here. Oh, you're not quite on, I think.
You know?
There we go.
Good.
Awesome.
I apologize if this is a novice question.
No.
You talked at the beginning of this discussion about certificates. Could you talk a little bit about how those certificates are administered and distributed? I'm aware that there are certificates on the access points as the vendors deliver them. There are certificates on the controllers. Can you talk about how that works?
Absolutely. Great question. So one of the things that we wanted to do to enable cloud scale, if you will, for operators to be independent of any infrastructure, if you wanted to. I mean, you could be an incumbent operator and have all of the infra going to and from the customers that you're serving, but they may not always be the case. Or you may be that type of incumbent operator, but you want to expand your footprint into other operators' networks that you don't have that infra. So what we really needed to be able to do was have that sense of independence. And so to do that, we wanted to maintain security at a distance, and we wanted to ensure that we had unique identification of every single device. So TIP worked together with partner DigiCert to create a root CA that allows for both a server-side certificate as well as a device certificate to be generated. Now, the server side is for the controller. In the case examples we went through here, that's the OpenWiFi gateway, the entity that speaks southbound to devices. Devices themselves will require a per device unique certificate. So a manufacturing partner of OpenWiFi devices will be part of the certificate portal system, and when they manufacture a TIP-based SKU, they will generate a certificate for that device at factory. So they'll apply one of the TIP AP NOS images that came from the GA quarterly release, for example. And when that image is applied, they'll make a call to using the portal service to say, I need this unique ID to have a certificate, please provide. Installed at factory and then shipped. The same conversation occurs then for the cloud side. So if a controller partner is in the ecosystem, they're saying, I'm standing up a cloud instance, I'm looking to deploy a new OpenWiFi cloud, they request a certificate for that cloud so that devices that point to that cloud are able to obviously have that secure communication. Now, how is that administered? So we are just launching, we're a little bit proud of this, we hope it goes really well. We've just launched the client key portal that offers the community an easy way through a web interface to be able to generate server certificates and generate device certificates. Also to be able to update where a device points to in terms of one cloud or the other. And so that's just launching. We have a few of the partners right now on it and giving us feedback. And I think that maybe we'll have an update on the November PG call, how that's going, or, okay.
Expect to have an update on the PG call in November and officially launch. We have some of the operational infrastructure on the back end we have to put in place, but probably in November.
Okay. Did that help answer?
It gets administered by the manufacturer during the process. It gets applied to the...
At the device level, yeah.
Exactly.
But there is also a config that says this particular serial number is going to go to the server.
Correct. Up at Digiser, that's right.
So somebody has to administratively communicate the serial number is going to the server.
That's right. So there's a few ways to do that. So first is if you go back to that factory moment, the ODM partner could choose to define a cloud at that moment in time. That's a valid outcome. A lot of operators will purchase a specific SKU in their name. And let's say an operator is saying, I'm looking for 5,000 APs, and this is what I'm looking for, TIP release 2.7, and this is the cloud. So the factory has the ability to obviously take that version of the firmware, and they can generate the 5,000 device certificates with that cloud URL as part of the process of generating all of those devices. Now, also optionally is they could generate with no cloud URL. So this would be the use case where it's a general SKU, you're shipping it to anyone, and they haven't yet subscribed to a particular cloud service one way or the other. When that occurs, the certificate still gets created, but that value, because I mentioned earlier, that value of the cloud's not actually written in the certificate, it's held up in DigiCert. So the device will find that there is no redirector value. A natural result is it presents out a local web page and asks, where is my cloud? Now, there's another subtlety. There could be a distributor model. And so a distributor might say, aha, but I'm actually the person selling this device. And it didn't have a cloud set when I took, transient inventory and then sold it to the end customer. So I, the distributor, want to turn around and update that value. We go back to the certificate portal, and the distributor is now able to say, for any one or for any multiple number of devices that they're selling to customer A or customer B, set those cloud redirector values up at that time. So it's flexible in those ways to allow a lot of those types of use cases, and there's probably additional use cases that the community is going to come in and say, yeah, we get how those work, we also want to do these other things too. So I think the system's pretty flexible in that regard. But is that the root of your thinking on the question?
I think the root of my thinking is what is the scope for people to make administrative errors in the attribution?
Ah.
And if they do, what's the format for that?
Sure. So The fallback plan is actually the logic that's held inside the access point. If somebody has incorrectly typed in their cloud, like the distributor use case, right? It was sold to cloud provider X, but instead they punched in cloud provider XY. That cloud provider may not even be a thing, or if they are a thing, it's not their device, and they're probably going to disallow the association. Either way, there'll be a failed connection to the cloud, which means the device will launch its local UI and say, I couldn't connect to the cloud. You need to provide me a valid cloud location. So that's the ultimate fallback. If all else fails, you'll end up being prompted with a local web page.
Which you have to be on site.
On site to do, that's right, because you have no connection to the cloud. Yeah.
I'm trying to think how organizations deal with
Sure.
an environment where your field techs, you don't really want them involved. You want
Sure.
them not involved.
There also is a way in which you can, and this was a recent contribution from the community, you can listen for cloud direction by DHCP option. Yeah, aha. So that's also a thing. So you need only properly configure your specific scope for your premises, and then the field tech, I mean, if the lights go green, the lights go green, and they're happy. You can also obviously call the API onto the stack and look at the current status of the device to know that everything's alive and well. But to that last end of, I don't want the field tech to be involved, and I, don't want any other involvement regarding this redirector, you can also do it at the DHCP level.
So you could instantiate something like DHCP and then leave it to operate.
Indeed, yeah. Yep.
Yeah, does OpenWiFi have a way to handle the what's typical in MDU roaming dense environments that Ruckus does with the DPSK?
Mm-hmm. I love this question. This is like my favorite feature. So the first thing to make adamantly clear is it's not DPSK. So we call it MPSK. So indeed, multi-PSK feature in OpenWiFi does exactly what you're thinking of there. So there's two ways to actually look at MPSK functionally. You can run it as a locally configured set of users, essentially as a list inside the APs in a venue. That's possible. But more often than not, what folks are looking for is, I'd like this to work in conjunction with my Radius back office. And so we naturally do all of that across a venue. Yeah.
Because we assign like VLAN tags,
Mm-hmm.
and that's what you're talking about when you're
That's
doing
right.
it with the controller.
That's right. So if you did it as a local configuration, you're setting up essentially a tuple in a list. This is this UE and VLAN. If you do it through Radius configuration, you're inheriting that VLAN association from Radius's response message back to the AP at the moment of time. Yeah.
Earlier, I think you mentioned that an end user could set up their own SSID.
Yeah.
But if they do that, they're going to lose the roaming capability, I would assume.
Yeah. I would imagine that would be a fair statement, for sure. There could be a way to think that through.
Because we do have instances of where a user, interestingly, people from the security industry come in and they say, "There's no way I'm going to use this this network because it's everybody's got the same SSID, and even though we're giving them their own version of the MPSK or and so they want to do their own. But if they do their own, then effectively they're limited just to the device that's in their particular unit that they're going to be able to do that.
Yeah, I mean, I think there could be creative ways to envision a solution in open Wi-Fi terms to that. And again, the PSK is going to give you a challenge that'll allow you then to be bound to that VLAN for the eternity of your session or the eternity of your life inside of the Radius backend. There could be ways in which you could stitch the topology together. I'm thinking maybe through VXLAN that puts together the home with the rest of the common network, but I would immediately get worried about leaky data, right? So, we've got client isolation on Wi-Fi side, client isolation, or I should say host isolation on the wired side, and all of a sudden it would be kind of suspect who's who in the zoo there if we allowed those types of things. But I think maybe that's kind of the interesting value in OpenWiFi is that it does have a lot of the push and pull moments. You could possibly create a solution that would allow you to get there from here. I don't know, John, can you think off the top of your head anything that might allow someone to have a private home network but then also be supported by roaming into another Wi-Fi network in the same premises? Yeah, so the traffic would be isolated.
I'm sorry, I didn't know what he said.
Yeah, so John was mentioning that your group key would be different. You would be isolated, two different networks.
Yeah.
Yeah, it wouldn't come into focus, yeah.
Yeah, and while I have the mic, I have another related or unrelated question. Is there something in OpenWiFi that handles channel and power optimization for when you set up a very dense environment?
Yeah, there's a few things. So first is the functionality of USteer, which is built in at the firmware level. So the devices can run in an autonomous local RRM mode, as it were, and you can turn on essentially auto channel selection as well as client steering in that configuration. You set up the rules that determine how those are going to behave. So you would set up what is the minimum signal strength that a probe response will be acknowledged through, and you'll set also you also set the kick threshold. So as a client is beginning to move, right, as they get essentially start approaching back to that minimum probe response threshold, you're going to start to say they're moving away. I'm going to send them a deauth, right, imminent, and get them to go to another device proactively, right, in the topology, and it's sent over the DS, information on the air side of that. You can also drain devices because if the AP gets too busy, there's a total load factor that's also set. If you 70% or 80% load, then don't auth or don't allow any probe requests, that sort of thing. So that works from a client perspective. Band steering's built in by default. I prefer 5 gigahertz or 6 gigahertz if present, that sort of thing. Then there's also the ability to look at through the intelligent channel functionality in USteer. When the device boots up, it'll exchange over the air interface who's who, right? Am I the newest one here? Okay. Let me quickly do a channel scan and determine the least busy and least noisy area in which I can operate. It makes that decision. It will hold that down for 12 hours. And it'll rerun that same algorithm at the 12-hour interval mark. All devices that are in that particular topology will rerun at 12 hours interval to determine should they remain on that same channel or not. So that's all the sort of the local features of channel selection, client steering, band steering that come in with the USteer functionality that's built in at the AP level. And we also have the ability to run from the cloud. So I mentioned earlier that the meta connectivity folks contributed to open source the RRM microservice. And so in that microservice, it's looking at instead of maybe a single venue of topology, it's looking at many venues of topology, sort of the large-scale view of RRM. Off the top of my head, I think we lost Krishna, but there are 4 different algorithms that are present in the open source RRM service today. And so some of the client steering and per client transmit power, those sorts of things are present in the open source RRM. So you can run, obviously, from the cloud your RRM-based decisions and get the same sort of rich KVR functions that you'd expect down in the premises from there.
Is it true, and I think my engineers tell me this, but is it true that if you change the channel, that a device that's trying to maintain a persistent connection is going to have to reconnect?
So it depends on how you change the channel, but yes, that can be an outcome. You can try to get the client to move to the channel you desire them on. If the client either chooses not to obey that or simply doesn't implement that ability, then you end up in a static sort of environment where the channel is changed and it's left someone behind.
Okay.
Yeah.
All right. Thank you.
Thank you.
You talked about multiple pre-shared key.
Yes.
And you talked about the 2 deployment options,
Yes.
the local list and the radius option. Does the radius option require special business logic in the radius server? Or is there some special source? inside the controller or
So,
the access point.
so, so I guess two things to offer. So one is there was a recent open source contribution to FreeRadius that helped multi-PSK work well. So that was recently upstreamed to FreeRadius, I want to say early summer. So that helped out with how FreeRadius would work with multi-pre-share key functionality. And that was because a very large operator on the previously mentioned vendor implementation of said type of feature basically we're asked to do this in an open manner from the authentication side. And so they agreed to work together with Alan DeCock from FreeRadius and see that would then all work together. So we inherited that goodness and allowed us to test our implementation to the same outcome. So that happened at the FreeRadius level, so that's open source and available for everyone. The other thing that we do that I think might be interesting is that we don't assume that you have control or governance over the customer's premises. And so a lot of the customer prems are going to be in private space, maybe that you can't necessarily route to easily from your authentication back office. You don't need to necessarily build a hard tunnel in to the customer's premises or put authentication on-prem. We allow you to configure an OpenWiFi access point to send all of the auth requests over the exact same WebSocket that's already going to the cloud. And then we implement a Radius pool at the gateway. So when you configure a Radius pool, and we do the exact same thing for RadSec, I think you mentioned earlier Orion. It's exactly how we tested Orion, by the way. You then end up having to only maintain one set of keys in RadSec perspective. But either way, you're sending your Radius messaging through the existing WebSocket. You break it out at the gateway in the cloud inside your managed environment, and then that gives you the ultimate flexibility. You could do this at a venue level. You could do this for your entire deployment. Whatever makes the most sense for how you want to send the Radius pool traffic. Okay, awesome. Okay, so we'll jump over to John, who's going to take us through development on the OpenWRT stack. John, thanks so much.